Here's the latest update here. Just tweaking it a little bit now because I had a wire that was a bit loose, but I fixed it up. Now this is my frequency generator. This is based on the 7.8 hertz Schumann resonance. I derived a bunch of Fibonacci numbers from it, and I calculated the capacitor values for the ceramic capacitor banks inside for this circuit here. Now this circuit has a few mods to it. Inside the circuit I've got a modified polarity indicator, so instead of having a single LED or flash LED running off the AC output, I have a modified polarity indicator with both flash LEDs on it. So when the AC signal flows one way, the first LED flashes on and off and it pulses that signal. As the signal goes around and stops and goes back the other way, it goes through the other LED and pulses it and flashes that one on and off too. So that one flashes on and off and pulses AC. So basically, both halves of the AC cycle are being pulsed or flashed and something like that anyhow. So this is what it sounds like if I switch it on. They look like they're out of synchronization, but sometimes they sound like they're in sync. And the next one. See? At different frequencies, they sound like they're out. Right, now if I flick that off, I just got a single tone. Now like I said, the modified polarity indicator has a flash LED on it. So I've got wires running from the modified polarity indicator, the flash LEDs on it, from the single LED output that bleeds off the AC output. So every time the AC socket goes through one LED, it pulses it, or it flashes on and off and pulses that cycle. And the other half of the cycle, as it goes through that one, there's a return cycle or whatever, it flashes, the green LED flashes on and off and pulses that one. Now sometimes those sounds, even though they sound like they're out, they sometimes sound like they're nearly in phase with each other. I don't know what that relies on. But anyhow, that's sat there. Now I've got something else to show you here. This is a static charge sensor. This is a 4011 logic charge sensor. This one here gives you the logic high and logic low. And if you guess, yes, it's a modified logic probe used as a charge sensor circuit. Now the copper plating enables you to biologically ground your thumb to it, so you're actually part of the circuit. In fact, there's no capacitance in the circuit because you are the capacitor yourself. Your body holds the charge or static charge where your body's holding it like a capacitor would. So that makes it much more sensible by grounding your thumb to that there. I've got another one here. This one here is a 4093 Schmitt trigger sensor circuit. It's got the same LEDs, high, logic low on it. And you ground your thumb to that one. This one's very sensitive. This one can sense static charges even in rain, moisture environments. If it's raining or it's cold or cool or moisture, whatever, it can still sense it. In fact, these both do the same thing as that approaching receding charge sensor by the man called O'Hearn on the internet does. When the charges gets closer, the low LED goes out and the high LED comes on, and vice versa and all that. So that's that there. And the 4093 is basically this here. This is not a printed circuit board one. Now this one here and the other one here are not exactly the same circuit. One's got different wiring than the other one because I use more of the taps on the integrated circuit than that one there. So that one's much more sensitive than this one here. So it looks in here. These are the charges. They're good for paranormal activity in ghost hunting areas, or if you're in the area where there's a Sasquatch and he's got a heavy charge on his fur and like static electricity, this thing will pick it up, and anything that he leaves a charge behind, it will pick it up as you approach it, or as you move away from it, or if it comes near you, or it moves away from you. The LEDs will respond accordingly. So it's basically like approaching a receding charge centre, and because you're biologically grounding your thumb to it, you become part of the circuits, and there's no capacitors using the circuit because you are the capacitor yourself, because your body is holding a charge just like a capacitor does. So if he's got a static charge on him and he comes near you, you gain the other charge, or a tree near you, or whatever, and this thing will respond accordingly. So these are pretty good ideas, these. Okay, thank you for watching my latest update.